Now, of course, those were and inequalities we just talked about in the last video. Um, this video, we're going to talk about another kind called a union, and this is, we also call it an or, but the idea behind it is we want either of the relationships to be true. They can both be true, just one of them can be true, and the other one false. That's okay. So let's kind of take a similar approach here. I think I used -4. What did I use the first time? -2. So x is less than or equal to -2. So that graph, I'll do it in green here, it looks like it's at -2 with a solid dot and everything pointing off to the left. And then for the next one, let's have x greater than 4. So in this graph, I want an open dot at 4 and an arrow pointing off to the right. You can see here there's no overlap. So it's different from the last one where the overlap was the part we were actually interested in. Here there's no overlap. All we do is bring each side of it down, and I get a solid dot at -2, an arrow off to the right, an open dot at 4, and an arrow off to the right. I think I said to the right here. It's an arrow to the left. I got to remember my left and right here. And that's what the graph looks like. The way we write this is pretty simply a is less than or equal to -2, or x is greater than 4. And we actually use the word or pretty commonly here for this one. For the other one, you could use and or, write it in that compound way. It doesn't really matter. Here, we want to use the or. And the way this works is there are solutions on the left and solutions on the right, but in the middle, there are no solutions. So what does a no solution look like here? Let's take 0. Is 0 less than or equal to -2? Nope. Is 0 greater than 4? Nope. So it's not true for either of those things. Whereas if you take a number like 5, is 5 less than or equal to -2? Nope. Or is 5 greater than 4? And this one is a yes, it is greater than 4. So 5 is a solution. It just has to be true for one of the two inequalities, whereas with the and inequality, it had to be true for both of them at the same time. So that's an and, or this is an or inequality. The last one was an and inequality. Let's try one on a problem. Example 2, write and graph a compound inequality. The human ear can only detect sounds between the frequencies of 20 Hz and 20,000 Hz. Write and graph a compound inequality that describes the frequency of sounds humans cannot hear. So they can hear between these, but I want to say what they cannot hear. Well, the number line for this is pretty easy, because I'm obviously not going to draw out 20,000 little tick marks, but 20 is definitely less than 20,000. So I just need those two numbers there. And now I need to think about what's describing here. So there's basically 3 sections of the graph, centered around 20, 20,000, and above. So you can see there's 3 different regions here. Which is the region that we want? We want to identify where humans cannot hear. Well, right now we only know where they can hear. It's between 20,000 or 20 and 20,000. Can hear, cannot. And if we want to identify what cannot, it looks like where the arrow's going out. So here's my final graph. 20, 20,000. And it says the sound's between 20 hertz and 20,000 hertz, so that must mean that they can't hear those. So here I want to have solid dots. The dots on this one in particular for this word problem is a little bit goofy because they're not very clear on whether 20 hertz is something that you can hear or can't hear. So I wouldn't be too worried about that. But for this inequality here, which does it look like? Does it look like an AND that I said was like the dumbbell shape, or does it look like an OR where they're pointing away from each other? To me, it looks more like an OR situation. So I want, let's just call it H for hertz. I want hertz to be less than or equal to 20, or hertz greater than or equal to 20,000. And there is my compound inequality. So when you're coming to trying to graph, you figure out the number line, you figure out the three sections, you decide which section you want. When it comes down to the final image, just by knowing do they go together or do they go apart, tells you whether it's an AND or an OR. So that's what I would be focusing on for that. Then of course you just have to decide, do I want solid or open, and then what are those actual number values, and you fill in the rest that way.